Hi! There are 4 sections of this course. In the beginning of our journey, we'll focus on kind of a speedrun trying to run the application and explain all the concepts behind the Nest.js. I named this section Course Introduction. In the second section, we'll add some business logic to our app and create some kind of prototype of the real application. I named this section Skeleton of an Application. In the third section, I mentioned the topic of persistence. Nest.js approach to this layer is really mature one. We'll create a real persistent layer of the application. In the fourth section, we'll focus on testing. I will talk a little more about unit and end-to-end tests. I'm going to differentiate those two types and show you how to correctly do both of them. All of this section will focus on basics of Nest.js, but it's not the end of the journey. I'm going to constantly develop the course and mention all the interested topics connected with Nest.js. There are many of them everywhere around. If you are interested in something, please write to me and I will take a look at your proposition. Thank you, and I hope that this course will help you to achieve your goals connected with Nest.js. Hi! In this section we'll do a Hello World application and explain the main concept behind the Nest.js framework. I would love to strongly focus on dependency injection and dependency injection container because it's the foundation of the framework. Enjoy your Nest.js adventure in the next lessons in just a minute.
Hi, welcome to this section of the course. Before we start to discover Nest.js power, we need to do some preparations. We need to have, of course, a PC with an operating system. I will work on Mac, but it's really easy to work on other operating systems also. I will show you an agenda. We'll set up brew, git, and VM. Node.js, we will talk a little about code editor, and we will set up Nest CLI. I'm going to use brew as a package manager. I'm familiar with it. You can use package manager of your choice. There will be different package manager for different operating systems. To install brew, you just need to enter brew.sh and copy that script to your terminal. And of course, press return. And in just a few minutes, a few seconds, you will have brew installed. Yeah, brew is already installed. And the second thing is git. Git is a version control system. It's easy to install it with brew. You just need to type brew install git, and in just a few seconds git will be installed. If you have other operating systems, you need to visit the official page and check getting started installing git section. There is a detailed instruction for Linux, MacOS, and Windows. Yeah, git is already installed. And we could install Node.js directly, but it's quite comfortable to use Node version manager to achieve such task. We will use NVM in this course. There is also alternative called N available. There is not a huge difference between them. There are some slightly differences in node paths. Both tools can be used in a similar way. To install NVM, you need to visit the official NVM GitHub page and check install section, copy this path, this script to your terminal, press enter, and in just a few seconds you will have the NVM installed. You need to reload the terminal. We will use just a new one. And finally, we will need Node.js. I recommend to use long-time support version. When I recorded this course, the newest long-time support version was 10. There is a schedule available on Node.js Foundation page with the past and future releases. You can check it and use the newest one. As you can see, currently it's Node 10, but it will be Node 12 in the future. You can simply install Node.js using nvm install 10. This command will install Node.js and npm. So we'll check in a moment if everything works correctly. Let's check node version. It's 10.15.3 and npm version, it's 6.4.1. Few words about code editors. It's of course possible to create an application in Vim, but I recommend to use dedicated editor with TypeScript support. It gives a lot of benefits. I'm using Visual Studio Code. It's free with a lot of features and plugins needed in everyday professional work. Remember that editor is only the tool. If you have preferred one, don't change it. Just ensure that your editor can handle TypeScript code. Look for some nice plugins if needed and enjoy. I will use some additional plugins also. Probably similar plugins are available on other sources, on other code editors. So, last but not least, we will need Nest CLI. We can simply install it using npm e-g nest.js/CLI. It will install, of course, CLI of Nest.js framework. It will take a few seconds, and in just a few seconds, we will have Nest CLI installed. Yeah, and yeah, here we are. Nest information. Yeah, Nest CLI is installed. Okay, so we installed all required prerequisites during this course, and in the next section, we'll create Hello World application. See ya in just a minute. Hi, and welcome. In this section, we're gonna create a Hello World application in Nest.js. It's really easy. Let's check the agenda. We're gonna create a new Nest.js project, open the project in Visual Studio Code, and run our application. So, as I said, creating a new Nest.js project is really easy. We'll use the CLI to generate a new project. To do so, we need to just type nest new. It's nest new, and just choose the name. In our case, it will be Hello World. And as you can see, Nest asked us about description. So it might be Hello World application. We need to also set the version. It might be 0.1.0 because it's our first version. And the author is me, so David Dominiak. And yeah, we need to also choose our package manager. In this course, we're gonna use npm. You can also choose Yarn. I prefer npm over Yarn. I was using Yarn for a long time, but I switched again. There are some reasons. Yarn log formats are different for different Yarn versions, so we need to sync Yarn versions in the whole team when working together. The same problem is with npm, but it's much easier to achieve it with npm because of Node Version Manager. Additionally, I've heard a story that Yarn is keeping private packages from GitHub on its own server. I didn't confirm that. I just switched to npm with version 6. I think it's not worth option now. Okay, everything is set up. There is some problem with Git repository because some files are not excluded, and our editor wants to create some missing Git ignore for us, but let's ignore it for this moment. As you can see, our application was generated, so we can open it. We can open this folder just by clicking application. Yeah, and we can open the terminal also. To run our Nest.js project, we need to just type npm run start dev in our terminal and press return. As you can see, the Nest application is starting. And we can see what happened in our browser. We need to just type localhost and 3000. It's our port. And as you can see, our application is properly created. Application hello world appeared. And that's it. As you can see, application bootstrap is really easy. You just need a few steps to achieve it. That might be a little confusing for you how everything is working under the hood, but I will explain it in just a minute. Hi and welcome. In this section, we'll look into the structure of generated application and we'll see what's happening under the hood. I decided to divide this section into two parts. In this part, I will explain the common concepts of Nest.js like module, like controller, like service, and in the second part, we'll check how to test Nest.js application. We'll see the scripts available in package.json and talk a little about them. In the end, we'll check TypeScript linter rules, and I will show you how to extend it. Let's check the detailed agenda of the first part. As you can see, we'll do the first commit. We'll check the main TS file and Nest factory class. We'll check app module TS file and app module class, app controller TS file and app controller class, and app service TS file and app service class. Before we start, we'll do our first commit. I will publish the whole repository on my GitHub, so you can synchronize with me in any moment. But before we will do the commit, we need to create an additional file called gitignore. It's needed because we want to ignore the whole node modules directory. And as you can see, Git doesn't see the node modules directory anymore. So let's add all our files and do the first commit. Let's name it first Nest.js course commit. And yeah, here we are. Let's come back to our main topic. Let's go to source directory and check main.ts file. Main.ts is an entry point of Nest.js application. As you can see, there's something like Nest factory here with method create, and this factory create method returns an interface. Interface iNest application connected with iNest Express application. It's not required to use Express. Express is just a default choice. As you can see, this object is returned to constant app, and there's a method listen. App listen ensures that app is listening on given port. In our case, it's 3000. As you can see, there's an import of app module here on the top. So let's see our app module. What's the monster behind it? The concept of modules isn't new for developers with Angular background. Module is a class annotated with module decorator. It's really important concept of Nest. Nest modules are not connected with TypeScript modules in any way. As you can see, these are TypeScript modules, and Nest module is something totally different. We should treat a module more like a bundle. So, for example, our application can consist of user module, product module, and payment module. And what's really important, our module can be nested. So in our example, product module can consist of product search module or product order module, etc., etc. We'll come back to this concept later. For now, it's important to remember that Nest modules differ from TypeScript modules, and we should treat them more like bundles. Such bundles can be nested. So, there are two other classes declared in our module decorator. There is an app controller and app service. Let's have a look at them, starting from app controller. Controller is a class controlling the entry flow. There are two important things to notice inside this class: constructor, and this get hello method. Nest dependency injector injects the arguments into controller constructor automatically. I will explain details about dependency injection in one of the next courses. If you are not familiar with dependency injection container concept, just assume that arguments appears magically inside the constructor. This construction, private read-only app service, might be new for some of you. It's nothing terrible. It's just an equivalent of something like this, like a declaration here, and this app service. Yeah, it's the same, just it's different way of doing that. I think this shorter way is quite understandable, so we will use that shorter way in this course. Look at this method, get hello. There's a get annotation here. This annotation tells us that this method should be executed when we send a request with method get. Get annotation can have an argument, and argument is a path. If you remember, we had the hello world sentence just right after we started our application. So let's start our application again. We need to do npm start, and in just a moment we'll see our application listening on port 3000, but we have 404 error. What's going on? Let's go to test root, and as you can see, we can see the hello world sentence here. Okay, so as you can see, we have something like app service injected into our constructor. Let's have a look at that app service. Services are classes with business logic of our application. Well, applications have really small and light controllers and business logic hidden behind the service layer. Service layer is reusable, and many controllers can share the same set of services. Other parts of your application, like CLI script, can also share the same set of services and de facto the same business logic. The pattern allows you to avoid potential code duplications in the future. Services should be decorated with annotation injectable, which means that this service should be a part of dependency injection container and should be injected into other parts of the application. Such services can be injected to other services or controllers. So I think that I will thank you for this lesson. I hope that the concept of controller, service, and module have been explained. I will explain the meaning of the rest of files in the next section. See you in just a minute. Hi, and welcome to this section of the course. We'll continue looking under the hood of Nest.js. Let's check our agenda. We'll check how the unit tests are written, same with end-to-end tests. Then we'll check the package.json and the written helper files. And in the end, last but not least, we'll check TSLint and how it's set up, how can we extend it, and so on and so on. Let's start with unit tests. The example unit tests are written already. Files.spec.tsr unit tests of our application. It means that unit tests are stored in such files. Unit tests should be simple, fast, and independent. If you can't write simple and independent tests of your method, probably you just did a wrong method. Our application example looks quite simple. Believe me, it's fast and it's for sure independent. Let's check it. You don't have to believe me, we will check it. All slow actions and methods of the tests should be mocked. We'll do mocks in the future for sure. For now, let's check how to run such tests. And to do it, we need to just use npm and the command test. And as you can see, we'll have the one test passed. Yeah, everything looks great. So we can switch to end-to-end tests. And the example end-to-end test is here. Blackbox tests of all endpoints are called end-to-end tests. I personally prefer the name integration test because I personally think that the word integration in this case would fit better. The name is different and I don't want to create an additional mess, so let's call them end-to-end. End-to-end test checks endpoint of our application. It might be, for example, REST endpoint. Test checks if a request can be executed and if endpoints produces proper response, consists of proper status code and properly formatted response message. In our example, we are requesting the previously created Nest.js application, and we expect 200 status code, and we expect hello world response message. And let's try to achieve it. Let's try to run our integration end-to-end tests. To do it, we need to just use npm run test end-to-end, and yeah, in just a second we'll have one test passed. I think it's pretty simple to run it, and we can switch to package.json. There are some helper scripts in our package.json from the top to the beginning. There is a build script. It just builds our application using the TypeScript compiler. Formats our code using the instructions defined in prettier.rc file. It's here. It's quite a nice feature. Start is the default start. It uses TS node to just run our application. Start dev, on the other hand, is watching for our changes. Node daemon is watching for our changes and restarts our application if there is a need. Start debug looks similar to start dev, but it additionally opens a port to debug application. I personally had some troubles to use the script with Visual Studio Code Debugger. I have checked script to use with built-in debugger, and I can demonstrate it. I already changed the configuration. As you can see, the configuration consists of the name, which is debug. There is an argument, which is the main file of our application. We just need additional runtime arguments like no lazy, which means that no lazy loading will be included to our debug script, and we require additional tsno register file to ensure that the TypeScript files will be pre-compiled before debug. We are doing everything in root directory, and we are using the newest Node protocol, and everything looks great. Let's try to use it. Yeah, everything looks great. Everything started. Let's try to use localhost 3000, and as you can see, debug point was handled, and we can see the whole context here. We can check what is this, and this has an property app service, like expected. We can have an access to the console. Let's check this app service. Hello, get hello, and we are expecting the hello world string. Everything looks great. We can go step into our application in our call stack, and the next step is just an app service. Everything looks great. Everything is working. I don't know why I have some troubles with the default script. Let's come back to our package.json file. Yeah, we are here, and there are two strange scripts, pre-start prod and start prod. Both are running a compiled version of Nest.js application. The first one is compiling and the second is running. The question is why the version must be compiled. It means why we need to compile the JavaScript code. It don't have to be, but remember that compilation takes time and resources. To make applications scalable, we should run additional instances on our infrastructure without the huge load. The lower the load is, the better. Pre-compilation before a release reduces the load, and application needs less resources on startup. It's not an accident, it's thoughtful concept. Additionally, there are scripts to lint test with watch, test coverage, test debug, and we can also use test end-to-end. We did it already. So I think it's all. So we can switch to tslint JSON. Last but not least, tslint JSON file. All lint-related stuff can be can be set up here. By default, lint extends tslint recommended rules. It's a base set of rules. I strongly recommend usage of more strict set of rules in your professional project. I can recommend tslint Microsoft Contrib package. It's available on the official Microsoft GitHub page. Let's go to the installation section. It's here. We can just copy this script, paste it to our terminal, and in just a few seconds we'll have tslint Microsoft Contrib. We'll need to update also the tslint JSON file by adding the roles directory, of course, but it's not the one thing we need to change. We need to also change the extend method, and we'll save it, and I'm sure we're not so strict. Yeah, Microsoft Contrib is really strict. So I wouldn't be surprised if you will decide to loosen the regulation. Also, I strongly recommend to use tslint Microsoft Contrib in your production environment to create consistent code. I'm not gonna use it during this course. It would harm our lessons, causing additional overhead to maintain it. It's really strict. So I think I can thank you for this section, and see ya in just a minute.
Hi and welcome to this section of the course. I'm gonna show you one of the main concepts of Nest.js. I will explain how the dependency injection container works. So let's check the agenda for today. We'll see the dependency injection pattern, we'll talk a little about it, and we'll see the implementation of it in dependency injection container of Nest.js application. So let's check what's going on with dependency injection pattern. Dependency injection is a technique where the one object can supply the dependencies to another object. The practical implementation is quite simple and we really don't need Nest.js application at all. We'll need the real-life example, so let's create a file called assembler.ts to demonstrate such pattern. Let's create a new file, assembler.ts. Yeah, here we are, and let's import our service and controller and initialize them. Let's create our service then, but let's import app service from app service and import app controller from app controller. Yeah, here we are, and we need to just initialize them. We need to create const app service that will be an instance of app service class. We don't have to pass any arguments in this case, but we'll need to do it in just a moment because we'll create app controller, which is an instance of new app controller. And as you can see, we need to inject an argument here, and it must be app service. Yeah, here we are. So let's call also the get hello method. Let's create const hello, and let's call app controller get hello method. We can also log our output to standard output, so let's run console log hello, and as you can see there is some problem, but we can easily fix it because TestLint forbids us to use console log, but it's important because of some testing purposes to show you how it's working. We need to just run our assembler file. To use it, we can call npx, use ts node. Ts node is a kind of overlay over the node.js, and we can use TypeScript directly, and we'll run our assembler.ts file, and as you can see the response is hello world. It means response. Standard output is hello world, so everything looks great and it's working. What we just did is manual dependency injection. Assembly.ts file is not connected with Nest.js application in any way. It's just an example how to achieve dependency injection outside of Nest.js. Recognition of dependency needs and injection inside Nest.js application is a task of dependency injection container, which assembly all dependencies for us automatically. Thanks to that, we don't really need files like assembler.ts in Nest.js application. Nest is strongly using the dependency injection container. Dependency injection container makes dependency injection technique more automatic. All work that we done in assembler.ts file is done by dependency injection container. We just need to annotate injectable class like app service with the annotation injectable to ensure that container will take care of it. Nest.js container also reduces the visibility of current service to current module. That's why we need to also register our services in our module by adding them to module annotation. As you can see, app service is added here and app controller is added here. We can also easily change the service visibility, and we'll do it for sure in the next few lessons. So to sum up, dependency injection pattern is one of the ways to implement dependency inversion principle. If you are not familiar with it, it's one of the 5 principles collected into mnemonic acronym called SOLID, created by Uncle Bob. Necessarily Google SOLID and Uncle Bob if you haven't heard such names before. Thanks to dependency injection technique, we don't have to carry so much about dependencies. We don't need to worry that given dependency will be initialized many times and will cause potential memory leak. On the other hand, we are sure that all dependencies are initialized. What's super important, we can easily mock the dependencies and supply mock dependencies inside our objects. It makes the unit test faster and more independent. We'll do such things during the course, and I will show the practical example then. Dependency injection container automates our work, and we don't need to solve and inject dependencies manually. I hope that this technique is more clear for you now, and you will also see the benefits of using it. It's all for this lesson. Thank you, and see you in just a minute.
Hi, thank you for watching this section. I hope you enjoyed Nest.js. There were a lot of concepts and explanations here. The next sections are going to be more practical ones. In reference to the previous lecture, as a postscriptum, I wanted to mention that the difference between classic approach of services instantiation and dependency injection container. Please take a look at this image. There is a main class function called by main thread of the application. Inside this function, or other called indirectly, we need to instantiate all the services. It's difficult to manage the life scope of such services in such case. Let's have a look at dependency injection container approach. All that happens inside the dependency injection container, which is well tested and reliable. We are just starting the container bar by running our application inside the main function. I hope that those 2 pictures will clarify you this topic. We'll rely on this pattern strongly in the next sections. Hi, you know already the main concepts behind the Nest.js. In this section, we'll focus on the business logic of the application. We'll create our first module and a service inside. This module will also consist of a controller and both unit and end-to-end tests. We're going to make this app a modular one. Modular architecture is not a new concept. Application nicely separated to modules consists of smaller chunks responsible for its own. Such chunks can be developed by a smaller team separately, be separated to microservices in the future, or just create a network of self-documented small chunks to be easily understandable by new developers and easier to maintain. Please enjoy this section with me and Nest.js. See ya in just a minute.
Hi and welcome to this lesson. Before we start, I want to recap that you can synchronize code with me in any moment. Just enter my GitHub page and find the repository nice locations. You can easily clone this repository and check out to tag skeleton. It's super easy. Just type git checkout skeleton and you will be synchronized. You need to do it, of course, in your terminal, in your working directory. So let's check out again to master and let's check what we'll do in this lesson. And in this lesson, we'll just change the metadata of our application. It will be no more hello world application. It's gonna be nice location storage. So let's check the agenda for this lesson, and it looks quite simple because we'll just change the package JSON, we'll update package log, we'll change directory name and commit the changes. Let's have a look at the package JSON. We're gonna create an application being the database of nice location. So let's check
let's change the name of our application to nice locations. We need to change this name, nice locations, and the description to nice locations also. It's not the only needed change, because package.json is also not updated. As you can see, there is a name hello world, but we can just update it by npm install, and in just a few seconds this name should be changed. Yeah, as you can see, there is a name nice locations. We need to also change the directory name. It's super easy, just info hello world to move hello world to nice locations, and we did all needed changes, so we can simply check the status and commit our changes, and we can name it like change application hello world metadata. Our new application is nice location storage. Yeah, everything looks great. Let's push it to our repository. And yeah, we changed the metadata of our application, so let's continue create our app in the next lesson. Hi and welcome to this lesson. In this lesson we'll focus on setting up the template engine and generate simple page. Let's check the agenda. We'll install Handlebars template engine for Express. We'll do the changes in main.ts file. We'll create two directories. We'll create the first handlebar template. We'll check the contemporary unit test, and we'll set up controller to use handlebar template. At the end, we'll run the test and test our application manually. So let's start. We'll install handlebars, but you can choose whatever fits you best. Handlebars are great for me because they're super extensible. To install Handlebars template engine, we just need to use npm install save HBS, and in just a few seconds Handlebars will be installed. HBS is a plugin for an Express of Handlebars template, so don't worry, it's a proper name. We need to set up Handlebars in main.ts file also. To do it, we need to use the method appSetViewEngine, and it's super easy. appSetViewEngine and handlebars. Oops. Okay, and set the base directory of the views containing the views by method appSetBaseViewDirectories. Yeah. So let's think where we are in the directory structure. Our main directory is one level higher than the current one. So let's create a constant app directory. To indicate the application main directory, we need to use method resolve from path, and we need to use current directory name, and we need to go one level higher. So our base view directory will have a name views. So let's set up our base views directory in similar way. We need to resolve app directory and views. Let's format it a little better. Yeah, and what's worth to do also, it's worth to set up also publicly accessible resources using the method use static assets. Use static assets, and in a similar way we'll resolve our path to publicly accessible resources. Okay, main.ts file looks great, so let's create proper directories. We need to just create a new directory and set the name views, and the next one set the name public. Okay, let's add also the git keep file to public directory to keep the directory in GitHub, because we'll know at this stage we will not public any resources, but we want to keep this file in our Git. Okay, looks great. So let's create our first HBS template. Let's call it list HBS because we want to list our nice locations there. List.hbs, and let's start creating our first file. We need to create a doc type. We need to use HTML here, some header, it means head section. We will need for sure meta for charset. It's UTF-8 for sure, and we need the title, and in our case it will be nice locations. Okay, let's move to body section. We'll also have a header, nice locations, and yeah, we want to list our locations, so we'll use the handlebars template to list our locations. To do it, we need to use the plugin of handlebar each locations. Yeah, and it's a kind of a loop, and we need to access this location with this. Okay, it looks great. So we need to change the controller also, but before we'll change the controller, take notice that we'll need to change also controller unit test. So let's start with that unit test. The controller method will no longer return hello world. Instead, we'll have a method list locations. Let's create it here. List locations will return an array with proper locations. We also need to change expect method to this method to be to method to match object, because our object will no longer be the same. It means in this case it was a string, so we didn't care about instance of that string, because every string in JavaScript string is just a literal, but we will need to compare an object. In our case, it will be object with property locations, and there will be an array with locations. There will be location 1, location 2, and let's create also location 3. Okay, this test looks great. So let's set up the controller. It's last but not least. Let's go to our app controller and change the controller to use handlebars template. To do it, we need to just add render annotation, and we need to add the template that is going to be rendered. In our case is list handlebars. Okay, but we'll no longer use the method get hello. We need to change it to list locations, and we need to return something different than string, but controller should have a proper test already. We can, I think, test it, and this test should not pass. Yeah, one test failed, so let's fix this test. This controller will no longer return a string, so let's create an interface, a DTO, which will be returned. Let's create an interface I location list DTO, and it's going to be an object with property locations, and property locations should be an array of the strings. Everything looks great. We just need to change the returned value from string to iLocation list DTO. Of course, now it don't have to be, it must be an object with property locations, and let's copy our locations from here to here and format it properly, and everything looks great. Let's run our unit test to check if something changed, if everything works correctly. Yeah, one test passed, everything's worked correctly. To be sure that everything is working, let's run our application. Just type npm start dev, npm run start dev, and in just a few seconds, yeah, application is working. Let's go to localhost 3000. Yeah, as you can see, we've got the view with nice locations. We can now add the new location here, location 4, and in just a moment our location 4 should be visible here. As you can see, our application is running properly. Thank you for your time, and see ya in the next lesson. Hi and welcome to this lesson. We set up our controller and did the change in the unit test. To have a whole picture, we need also to run end-to-end tests. So let's run them by npm run test end-to-end. npm run test end-to-end. Tests are running, and as you can see, test failed. So let's check what happened. We expected hello world, but we got the whole HTML page in exchange. That's how templating is working. Do we need to compare the whole HTML content directly? Yes and no. But before we'll start, let's have a look at the agenda. We'll install Jest HBS extension. We'll create test setup file. We'll set up Jest. We'll update the Jest setup just, and we'll fix end-to-end tests finally. So I haven't found any out-of-the-box solution, so we need to do a clever one. I've prepared for you a Jest extension to test templates. We need to install it using npm, so let's install it by npm install safe dev Jest HBS extension. It will take a moment, but don't worry, we can just create a setup without that extension, we need to create a file test setup.ts in our test directory. As you can see, jest extension is correctly installed. We need to import our jest extension, and the default export of that extension is a function, and this function we can call add jest HBS extension from jest HBS extension. Looks great. To call this, we need to call this function, of course, but as you can see, this function will need the views path. It's a views path of our views, so let's create a constant containing the views path. And of course we need to resolve our path, and we need to get the directory name. We need to go one level up because we are inside the test directory, and we want to use views. Yeah, and now everything looks great. We can add this views path here. Our test setup.ts file looks working. You can notice that we are duplicating code. We already defined views path. We'll take care of it in one of the next few lessons when we'll talk about configs. For now, just remember that we'll need to fix it. So let's set up jest. Now we need to set up jest to use our extension. So let's open our jest end-to-end.json. It's this file. And what we need to do is to add setup test framework script file, and we need to indicate our test setup.ts file. Yeah, looks great. And now we need to fix our end-to-end test. So let's have a look at our end-to-end test. We are still expecting hello world. We need to change it. We can use promises to do it. We can use then here and get text and we want to expect that this text, and this is the new functionality that our extension extended the just expect method with a method to match compiled handlebars template. And we need to indicate our handlebars template. In our case, it's list.hbs. And we need to also check our pass our object. We need to pass object with locations. And there is a location 1, there is a location 2, and there is also the location 3. Yeah, everything looks great. Let's try to run our end-to-end test by command npm run test end-to-end. And in just a moment we'll see what will happen. Yeah, as you can see, end-to-end test passed. Everything looks working. Our extension works great. You can find detailed implementation on my GitHub page. Let's have a look there. Changes in our application can handle the behavior, can change the behavior of our test. Take care about it and do not forget to run all the tests. In one of the next sections, I'm going to explain how to set up continuous integration platform to run unit and end-to-end tests for us. Thank you for this lesson and see ya in the next lesson in just a minute. Hi and welcome to this lesson. During this lesson, we'll create our first module. So let's check the agenda. We'll generate the Nest module. We'll move controller and unit test to the new module. We'll run unit and end-to-end tests in the end. So to generate Nest.js module, we'll use Nest CLI. It's quite easy. We just need to type Nest generate module and we need to pick the name. In our case, it's going to be location, and in just a moment we'll have a new module created. So let's check what was changed. There's a new directory named location and file location.module.ts. There's a class location module inside this file, and if you look at app module, you will also notice that there's an additional information. Our newly created module is also registered in app module. From Nest perspective, app module is a parent class for location module. Let's move our controller and unit test to the child class, to the location module. To do it, we'll just need to move the files. Yeah, everything looks great. The paths were updated, I think, except this one. Oh no, paths wasn't updated. Let's update them manually, don't worry. We need to update this path and we need to update this and this. I don't know what happened. Normally this path should be updated automatically in this editor at least. We would like to change the name of these files also to fit better to our needs. So let's change the file and classes names to location. Let's change the name to location.controller.ts and the controller spec.js file TS file to location controller spec TS file. We'll also need to change the app controller class. Let's change it to location controller, and we'll also need to do some changes in test file. We need to change this variables to indicate location and use capitalize letter here. It looks great. I think that all app controller instances are removed from our files. We need to also move the controller definition to the location module. To do it, we'll need to create the property controllers in our module annotation and import indicate the location controller. But remember that we have also the controller, location controller, I don't know why it's app controller, here. It should be automatically updated. Sometimes it's not working correctly. I think that the newer version of editor will fix some problems. There is also the location controller. We need to save it because there were some changes. Yeah, everything looks great. We need to do something with that app service also. I think that we'll not need app service anymore. If we would like to create location service, we'll just create a new one. It's a really simple service, and you will check how to create such services. Let's remove the app service. We need to remove that file, and editor should indicate where such app service was. Yeah, it was for sure in the test. It's no more needed. The occurrence was in a controller. It's also no more needed. Yeah, looks great. In the end, we'll run our unit and end-to-end tests to check if everything works correctly. So let's start with unit test, npm test. Yeah, unit tests are working. And let's check end-to-end test. To do it, we need to just npm run test end-to-end. And in just a few seconds, yeah, end-to-end test passed. Let's start our application and check if something changed. Nothing should change. Localhost 3000. Yeah, everything looks exactly the same. So everything works great. Looks like application works exactly in the same way. We just have a nicely separated module with business logic connected with locations. Thank you for your patience and see ya in the next lesson.
Hi and welcome to this lesson. In the last lesson, we've created a module. Modules are really powerful tools in developers' hands. Thanks to them, we can reduce the scope of a big application to nicely separated modules. Each module can be maintained by a different person or a different team, so there should be loosely coupled connection between modules. The looser, the better. On the other hand, every module has its own structure consisting of controllers, services, and persistence layer. In this lesson, we'll focus on service. So let's have a look at the agenda. We'll not create a service interface. We'll generate a service, create a service unit test, and we'll implement the service. In the end, we'll inject a service to the controller. Some can argue that there is no reason to create an interface for every single service, and yeah, there was. The well-written application never had one class using a single interface because the second implementation was a mock. Do you remember what I said about unit tests? Unit tests should be fast and independent. Interfaces made unit tests easier because services stayed loosely coupled. Thanks that, we can easily create a light mock to be injected inside the service. But time is passing, things are going forward, and this is a problem of Java world of the early 21st century. Then Mockito came to Java. In TypeScript world, we don't have Mockito. We don't need to. We can easily create a strange construction like const whatever isn't just an object as app module. It can be easily injected as a mock to a tested service. Okay, stop with theory. Let's create a real service. To generate a service, we just need to run a command nest generate service, and we need to pick a name. In our case, it's going to be location. Yeah, as you can see, the service and unit test of this service
has been generated. So let's go to check what happened. There are new files with test and service and some basic implementation code inside. Service is also registered in our location module. As you can see, the service is here. So let's check our unit test. As you can see, the first test is written. I personally don't like the default Nest.js approach to write a unit test and generate a testing module before every test. It's adding unnecessary complexity and tests execute longer. Let's simplify it a little. Let's remove that module at all, and let's stick with the fact that our service is just an object location service. It should be enough, and this test is also not needed in this shape. Okay, before we'll change the test, let's create a method placeholder in our location service. Our method is going to list our locations, so let's name it list. It's public method, of course, without any arguments, and it will return the array of our locations, array with locations, and it's a placeholder of our service. So let's try to test it. It should return locations. So we are expecting that service list to be an array to match object. I think it's better to match object, and there will be location 1, location 2, and location 3. Okay, everything looks great. Let's check our unit tests. Let's do the command npm test, and as you can see, there are 2 tests, and 1 test passed and 1 test failed. It's expected behavior, of course, because we didn't implement our service business logic. So let's implement our service. We need to return an array with locations instead of just an empty array. For now, we will just return an array with location based on that service locations. It means based on just a strings, location 1, location 2, location 3. Yeah, and let's run our test again. And in just a few seconds, we'll have the result. Yeah, 2 tests passed, everything looks working. Let's use our service inside our controller. Injection is pretty easy because Nest dependency injection container will do the injection for us. So we just need to use our service inside the container. We will need a constructor, and we need to use our service. It's of course private read-only property with location service being a location service. It's automatically imported. Yeah, everything looks exactly like it should. And we will not return an array with locations here. We'll use this location service list. We can do it even better. We will create a constant locations and we'll bind it to the result of that method list, and then we will just return object with locations inside. Okay, looks working. Let's run our end-to-end tests. Test end-to-end. End-to-end test should pass because nothing has changed. Yeah, looks working. Finally, we'll run our application by command npm start. Application is running. Let's go to localhost 3000. Yeah, there are 3 locations, exactly what we expected. Okay, so it looks like we're not moving forward with our app, but don't worry. We created a really nice skeleton and shortly we'll do big things. It's really important to show you the right skeleton of an application. We'll shortly rapidly develop new features. Services are places to keep our business logic. Thanks that our logic can be easily reusable. It's really important to remember to keep controllers as light as possible and move business logic to the services, which can be easily unit tested and used not only via HTTP endpoints. Thank you for this lesson and see ya in just a minute. Hi, thank you for this section. We've created the very first module of an application. Such module consists of all business logic connected with locations. Nest.js module can be nested and will nest the modules for sure in the future. Such nicely separated location module will be a proud first chunk of the application. Let's come back to work in the next section in just a minute. Hi! Persistence is one of the 3 important layers of the backend application. Persistent layer allows us to store objects and access them in the future. Well-implemented persistence is using abstractions such as repository to make an object accessible without the knowledge of the real implementation. Thanks that the process is more independent, what means it is also easier to test and possibly refactor in the future. Let's begin our journey through the ocean of persistence with me and Nest.js. Hi and welcome to this lesson. I promised to come back with an explanation of the way to correctly handle the config of our application. Before we start, I just want to mention that I had to fix the location controller unit test. I didn't want to create an additional video to do that. If you are curious about the change, just visit the GitHub. Let's check our agenda. We are going to install config package, then generate config module and service. We'll create our first config and use our config inside the application. I know that there is a tip on Nest.js to use .env library. Let me show you something different, probably less popular but more powerful. We are going to install the config library. To do it, we need to type npm install save config in our terminal, of course. Yeah, in a moment we'll have config installed. Let's wait a minute or just a few seconds. Yeah, looks like config is already installed. So we would also need typings. Typings are available to install via npm install save for development, and we need to install types for our config library. In just a moment we'll have types installed. Yeah, types are already installed. So to nicely separate config from the rest of our app, we need to create a new module. Let's type nest create module, and we need to pick a name. In our case it's going to be config, and Nest will create, it's generate, of course, generate module config. Yeah, as you can see, config module is created. We'll also need a config service. So let's type nest generate service config. Yeah, and config service with unit test has been generated. Let's implement the config service. It's quite easy to implement it. We just need one method. It's method get. It's method which will have an argument key with a string, and which will return the generic type. So we could ask about any type we want, and we would return config I think we need to import it manually. Import everything as config from config, and now we can return config get. Also we need a generic type, and we need to pass our key as an argument. Yeah, the service is not complicated. Seems even a little not needed. However, remember how simply is mocking injected dependencies. We'll save a lot of time in the future. I didn't do any test. I will do for sure in a moment. Please open config service spec.ts file and let's implement the test. We will not need this section. Instead, we will initialize service directly using just close new config service. It's really easiest way to achieve it, and our test will indicate views location, because that's our task that we can extract to config. Let's create a template path. We need to resolve it by passing a dir name as an argument, As you can see, we are two level, our main directory is two level higher than current directory, so we need to go up and one more time up, and we will need indicate the views directory. In our case, it's views, and we would expect that our service get, and we are expecting string, and our service would give templates path, and templates path from our config will equal our constant. Yeah, looks good. Let's run it. npm test. And in just a moment, we will see. Yeah, right test is failing. That's because we didn't indicate the path. We need to create a config. We need to create a config file especially. There is plenty of available config formats to choose, like JSON, JSON5, YAML, but I would suggest to use TypeScript. TypeScript-based config will be consistent with the rest of an application and quite powerful. We can also do simple programming inside. So let's create the first config. Let's create the default.ts file in a directory named config. Default.ts, and let's implement our first config. We need to export an object with templates of our with template settings of our application. Templates would have a property path, and we would resolve our path using a directory name. It's, as you can see, one level. We need to go one level higher and goes to the views directory. Yeah, and it's our templates path. We would also implement our public path, and in this case it's resolve directory name one level up and the directory named public. Yeah, looks great. This should be single quoted. So if you remember what I said about Nest dependency injection container, then you know that we cannot inject config service into our modules. We should let the config module to export a config service to ensure that config service will be properly injected in other pieces of our application. So let's go to our config module and add property exports, and we are going to export our config service. Yeah, that's right. We forgot to run npm test to ensure that our config is working correctly. Yeah, everything is working. There is also a warning that we are running application with node.env test, and we don't have the config for test, but this is just a warning, so don't worry about it at this moment. The most important fact is that our test passed. There are two places where we need to inject the views path. As you remember, it's bootstrap, it's here, and we can easily access the config service from this main.ts file. To do it, we need to just use our injector. To have an access to our config, you would use the method get of our app, and we would like to get the config service. It's easy as it. We will no more need that constant. Instead, we will get the views directory from our config. We will also need the string, and we would like to get templates path. Yeah, and our views directory will be passed here. Yeah, looks great. We'll do the same with public directory, const public directory, and let's copy it. And it's not templates, instead it's a just public path. And let's copy it here. We'll also not need resolve from the module path here, and everything looks great. End-to-end setup is more challenging. We could run test Nest application with config service injected, but it's not needed. Let's go do that end-to-end setup. Do you remember what I said about services? Services can share business logic within HTTP application, but services could also be easily used also outside the HTTP or even outside the framework scope. Services are just classes containing the business logic. So let's simply initialize the service inside the setup file. We'll just need to initialize a config service. So const config service will be just new config service, and we will get the views path from our config service. We'll need a string also, and we'll get templates path. This constant is not needed, and resolve is also not needed, and everything should work. So let's test our end-to-end test, npm run test end-to-end. Yeah, end-to-end test. There is just a small problem with paths, but we can easily solve it, and in just a moment we'll have end-to-end tests paths. Yeah, everything is working. Just a warning here, our unit tests were working also. So let's start our application. Yeah, let's go to localhost 3000. Yeah, everything looks working. So config library is really powerful. I encourage you to visit the official GitHub page of node config. It's the official GitHub page of the config library. You will see all the possibilities here. Different config files can be loaded, depends on environment variables. Multiple config files can be merged with each other. Application arguments or environment variables can override the current config, and that's really super that we have that feature. And there is a plenty of possibilities to meet the needs of our application. We'll discover more in the next few lessons and the next few sections. Hi and welcome to this lesson. In this lesson, we're gonna install PostgreSQL. So let's check the agenda. We're gonna install PostgreSQL, create a database for our system user, open PostgreSQL terminal, create a database for the application, and create application user. To install PostgreSQL, you just need already installed brew. Let's install PostgreSQL using brew install PostgreSQL. Look for installation instruction for other package managers and other operating systems. It should be quite easy. In case of any troubles, just ask a question in our course forum or go to the Docker section and install PostgreSQL using a Docker. Looks like PostgreSQL is already installed. Remember to refresh your terminal or just open the new tab. There should be a command in a moment. There should be a command create database available in your terminal. Let's use it to create our first database. Create database. Who am I? The command creates a database named exactly like your system user. Please run command psql to open PostgreSQL terminal. To create a special database for our application, we'll use SQL. Let's create a database. Create database locations with owner David Dominiak. It's me. Yeah, database created. So let's create a user for our application. Create user app with encrypted password app. It might be quite easy because it's only a local database, and our user must connect to the database and achieve it. To achieve it, user needs some privileges. So let's grant all on database locations to app user. Yep, and that's all. It's just a prerequisite to our journey to the persistence layer. Discovering more interesting corners is just ahead of us. See ya in the next lesson. Hi and welcome to this lesson. In this lesson, we're going to set up the connection between the application and Postgres database. Let's check the agenda. We're going to create database module. Then we'll install type_rm and set it up. We'll update config files and start Nest.js application. Database module seems not needed, but believe me, it is. There are plenty of issues related to the database, such as migrations or database config, and it's a good place to keep them all together. I hope it's one of the last not domain related module in this course. To generate database module, we'll simply need to type nest generate module database, and in just a moment database module is generated. We'll need to set up database connection. We're going to use type_rm, which is the default and the best ORM for Nest.js. To install type_rm, we are going to use npm. We'll also install Nest.js adapter and Postgres library. We'll need to type npm install save Nest.js type_rm type ORM itself, and Postgres library. ORM can be translated to Object Relational Mapping. It's a technique for converting data between incompatible type systems, relational and objective one. It's a quite common pattern in the programming world. Like every other pattern contains advantages and disadvantages. If you want to read more, please find my article on Medium, What's Up in Vietnam. To set up type ORM, we need to add dynamic dependency into the Nest dependency injection container. Dynamic modules are special customizable modules. There is a special module in Nest.js type ORM package which depends on some options. Our configuration should be quite big, so we would like to separate the configuration logic to separate service. Let's create a file Postgres type ORM config.service.ts in our database module. Let's open it. Here is opened already, and implement the database configuration logic. We'll need to export class Postgres type ORM config service, and we are going to implement type ORM. It might be not uppercase. Type ORM options factory. Yeah, because we'll factorize the type ORM options. We're going to implement it and import it from Nest.js type ORM library. I don't know why there are no suggestions. Let's check it again. No suggestions. So we need to do it manually. Import type ORM options factory from Nest.js type ORM. Yeah, and we'll need to implement the interface. Yeah, we'll need to implement the interface to create type ORM options. The return type looks strange because we only need to return type ORM module options, but it's a special Nest.js type compatible with that ORM options. In this case, we'll return an object with an options. We'll use Postgres, so type of our database is Postgres. It's hard to do it. Dynamic because we'll need to set up type of Postgres to Postgres ORM options, and it's quite common to use just one database. If we would like to migrate to other database like SQLite or MySQL, we would like to create new service and inject it into database modules. It could be quite simple. We'll need also URL, but to inject the URL, we need to inject the configuration into our class private read-only config service, and it's a type of config service. Yeah, now we can have access to this config service get, and we are expecting a string, not string, and we would like to use the path database URL. Yeah, the third option is entities. entities indicates where entities are, where can we find entities. It's a quite new word for you. So if you don't know what the entities are, don't worry. I will explain it in the next lesson. We'll need to indicate where the entities are placed. In our case, we'll get this value from config service, and it's an array of strings, and we'll get from path orm entities, yeah, like that. Be careful with that paths, because there are no suggestions. Yeah, we'll also need to synchronize our database. Depends on config state. We'll get this state, it's a boolean type, from orm synchronize. Yeah, everything looks great. To inject such logic into the database module, we need to add the imports property and import our configuration service to the database module. Let's create the imports properties, and there is a special module called type orm, named type orm module, and it's a dynamic module, so we will need to use for root section, but we would like to also we'll need for root section, and we'll need to import for root async section, because it's asynchronous loaded module, and we'll need to import our config module, and we would like to use the class Postgres type orm config service. Yeah, exactly like this. Let's fix the let's fix the lint, and everything should work except the fact that we don't have the proper configuration set up. Let's open the config default.ts file. Let's sort the current config in alphabetical order to reduce the mess, and let's create our config. We would like to create a database path. In our case, it's going to be URL, and our URL is Postgres app. It's login with password app at localhost, and our database is locations. We don't need anything more, and we'll need to set our ORM config also. In this case, it's entities. We'll need to indicate the entities, and we need to indicate the path. So let's create a helper to indicate the source path, and we are going to resolve that from current directory name one level up, and it's a source directory, and our entities are placed inside, are going to be placed inside, because we don't have any entities yet. Source path, and our entities will be placed under any directory and can be named like in any way, but will the final section will be entity.ts. Let's fix the linter, and we'll also need to decide if we want to synchronize our our application with the database or not. And by default, we don't want to. We decided to not synchronize the database because of the risk of inconsistency. The risk is lower wake on the local environments. So let's change this value for local running. To do it, we need to create a file local.ts in the config directory. And we are going to export default ORM synchronize and in this case it's going to be true. Yeah, and thanks that local environment will synchronize the application state with the database, and we need to synchronize the database on other environments manually. To ensure that everything is all right, we should start the application. So let's type npm start in our terminal. Something is wrong. Let's go to Postgres type URL config service. And we can see that we missed the injectable decorator, injectable annotation. Let's check again. Something is still wrong. Configuration property ORM synchronize is not defined. ORM synchronize, let's check what we defined here. Synchronize. Let's check what we defined in local. Everything looks okay here. Entities is defined, but in this case the ORM synchronize is not. Let's check if something changed after the setting it up. ORM synchronize, and it's false. And if we are going to set it like that, no, nothing is changed. Maybe something wrong with merging. Nope. ORM synchronize, and we are using int like ORM synchronize. ORM synchronize config service get ORM synchronize. Yeah, everything is running. I think that what was the problem? Yeah, there was a problem with a typo. Yeah, and let's uncomment it and change the synchronize to true. And let's run our Nest application again. It's really important to always check if your changes doesn't break your application. In our case, everything should work. Let's check on localhost 3000. Yeah, everything is working. So we properly set up the database connection. It's the first step to meet the persistence layer. Thank you and see you in the next adventure. Hi and welcome to this lesson. In this lesson, we are going to create a new entity. It's going to be a preparation for a greater refactor. So we'll break some tests for a few lessons. Don't worry, we'll fix them all. Let's have a look at the agenda and we'll define entity, create the location entity and inject location repository. Following Wikipedia, entity is anything that claims independent existence as opposed to merely being a part of a whole. Following the Eric Evans definition, entity is an object not fundamentally defined by its attributes, but rather by a thread of continuity and identity. Probably the most illustrative example will be the real one. So let's create a first entity in our application. It's going to be location. Let's create a file location location.entity.ts, and we are going to implement the entity. We will export class location, not the location entity, because it's easier to say just location. We'll have location name, not location entity name. It's easier and it's more common in a real world. And we'll have two properties. The one is ID and it's going to be a string, and the second one is name. It's also will be a string. And to create a proper entity, we'll need also some annotation. We'll need, for example, for sure, entity annotation. And as you can see, it's imported from type ORM. Let's change the double quote marks to single ones. And let's add other annotation. We'll need the annotation primary generated column, and we are going to use UID as our primary generated column. It will indicate our ID in the database, and we'll also use the column annotation. Yeah, our entity class looks like every other class. So on the other hand, there's a lot of meaningful annotations. Such annotations maps an instance of the class, an object, to relational tables in the database. Entity annotation marks our class as an entity. Primary generated column annotation is generating identity of our location. Column annotation marks property name as a volume that need to be translated into the column named name in the database. Type ORM automatically create location repository for us. Repository is a concept of an abstraction layer or a persistence process. Thanks that we don't need to worry about the way that objects are mapped and stored. We are just getting objects from the repository. Such objects are ready to be processed by the application and its business logic. To let TypeORM create a repository for us, we need to import TypeORM module for the location feature. Let's open location module.ts and add import property. We'll need to add the property and import type ORM module, and we'll need to do it just for one feature, and this feature is location. Yeah, and in that way we'll import the location repository. To inject location repository into the service, we need to use dependency injection. There is a special annotation inject repository to be used inside the service. Let's create a constructor for a location service. Let's create a constructor and we'll use annotation inject repository. Yeah, it's auto imported, and we'll import the repository for location entity, and this repository will be of course private. We are going to use location repository property to store our repository. It's a type of repository, but it's a generic type, so we'll need to use location as a generic argument. Yeah, our location repository is stored, so we would also change the list method to list the real entities. To do it, we'll need to return this location repository and use the method find. Yeah, looks great, except the fact that we are returning the wrong type and we are doing it not asynchronously. We'll need to use async method here, and we would like to return a promise for location, and much even more strict for an array of locations. This async is, I think, not needed in this case, but it will indicate that this is a synchronous function. Yeah, from our point of view, everything looks good. Repository is injected into the service, but we also break the rest of our app. Controller is expecting, as you can see, there's an error. Controller is expecting an array with strings from the service. The same with test. Yeah, test is broken. Some additional work must be done before we would test and start our app again, but we are on a good path. See ya in just a minute. Hi and welcome to this lesson. In this lesson, I'm gonna show you how to transform entities to DTO. This lecture might last long, so I decided to divide this lecture into two parts. Let's have a look at the agenda. We'll talk about DTO concept. We'll install Automapper, create a common module, create a mapping service, we'll implement mapping registry service, and we'll create location DTO. Finally, we'll create location mapping service. DTO can be translated as data transfer object. It's known pattern in the programming world. Thanks to DTO, we can fully control the output from and input to the application. DTO handles the correct data in the application borders. It doesn't have to be fully consistent with our entities, but it is mostly quite similar to the application logic. Thanks to that, we can simply map DTO to the entity and entity to DTO. Please have a look at the attached image. DTO are needed on the boundaries of the application. It's not fully true in our case because we are generating also the templates, but DTO exists at least on the boundary of the controller. Services and persistent layer are using entities on the other hand. We should map our elastic flexible DTOs into entities which are part of strict model of our business. We want to keep our API flexible for changes, but the business model shouldn't change in case of required API change. Not all applications need DTOs. It's especially useful in two cases. When we will programming for enterprise, where we will do the enterprise programming, where API endpoints are fully specified and there is no elasticity in the view of the API, or the second case is where API changes a lot. I promised enterprise ready framework, and I'm gonna implement DTO and all the mappings in the best known for me way. Possibly it's not needed feature in your application. If you want to read more about DTOs, let's have a look on that Uncle Bob page about data transfer object. It's linked under the video. There's a really great package dedicated to mapping in the .NET world. It's called AutoMapper. We're gonna install JavaScript equivalent of such package, and to do it we just need to do npm install save automapper-ts. AutoMapper will help us to map all the DTOs to entities and all entities to DTOs. We're gonna create for sure a common module to store something like mapping registry. I promise it's the last not domain related module. To create our module, we're gonna type nest generate module common, and in a moment module command will be generated. Yeah, it is. If you want to read more about the registry, please visit the Uncle Bob blog about registries. Registries are created to registry other object. We would like to store all the mappings. Let's create an abstract mapping service by creating mapping service.ts file in the common module. Let's implement that file. We're gonna export abstract class mapping service. Yeah, looks nice. We are going to self-register mappings in the register. To achieve it, we need to inject the register into all mapping services. To do it, we need to create a constructor with a mapping registry service, and it will be of type mapping registry service. We haven't created already, so we need to wait for implementation, but all the mapping services should have a method at mapping. It's abstract method at mapping, and this method is not gonna return any type, so it's void type. Okay, mapping service looks awesome. Let's implement a mapping registry. Let's create a file mapping registry service.ts. Now we can simply implement the mapping registry. We're gonna export class mapping registry service, and we are going to make this injectable. By the way, same with mapping service, it's injectable. We can now also, it's not double quoted. We can now import mapping registry service. Looks great. And yeah, let's go to the implementation of mapping registry service. And we're going to collect all the services into the array. Let's create this array. It's private, read only mapping services, and it's gonna be an array of mapping services. We can define it even. Mapping service. Array of mapping services. Yeah, we'll register all map services and initialize mappings. We are going to create a method register mapping service, and as an argument we'll get mapping service, and we'll push this mapping service to our mapping services array. Mapping service from the lowercase letter. Mapping service. Yeah, looks okay. And we are going to also initialize, instantiate that mapping. So we are going to use method add mapping. Yeah, looks great. And finally, we are going to use mapping by simply map the proper objects between incompatible interfaces. To do it, we are going to use method map. It's a public method map with generic type. As a source, it's going to be a class. Class name is a type of string. As a target, we are going also to get a class. And we are going to use any type of object and return the generic type. And to do it, to achieve it, we just need to use the automapper. What's wrong with automapper? Automapper is a global object, and we need to import it in that way. And it's gonna register automapper in our global scope. It's not the best solution, but it's really great library, although all the disadvantages. We are going to map this automapper from source to target, and we are going to use that object, and it's going to be a type of our generic type. Yeah, everything looks great. And do not forget to register the service in the common module. Let's go one more to mapping service, and now we can just register that mapping into our mapping registry service. Register mapping service, and we are going to register this service. Yeah, looks exactly like I expected. And we cannot forget about register the service in the common module. To do it, we need to create a proper properties like providers, and we are going to register mapping registry service, and we are going to export also this mapping registry service is a common module, so we're going to use that common module in our location module, and we're going to import common module. Yeah, looks great. Okay, we talked so much about DTO, but we didn't create any. Let's do it. Let's create a file location.dto.ts. Implementation should be simple at this stage. We're going just to export a simple class location.dto with a read-only ID and read-only name. At this stage, we are not changing the DTO, so it's quite easy to make it read-only. Okay, abstractions are ready, our DTO is ready, so let's create an implementation. Let's create a file location mapping service. Location mapping.service.ts, and we are going to export, and it's going to be a class location mapping service, and we are going to extend mapping service. Yeah, it should be single quoted. Yeah, now looks great. And we need to implement inherited add mapping method. And this implementation is quite simple. We are going to use automapper, create map, and we are going to map location entity to our location DTO. Yeah, this map is ready. And remember to make this class injectable. Yeah, looks exactly as we expect. We are going to register location mapping service into the location module. Location module, we already imported a common module. We need to also register location mapping service. Yeah, this implementation of location mapping service was trivial. It will not always be. I will show you shortly in one of the next few lessons why mappings might be needed. Some real use cases might help you to understand the need of DTO. Let's stop here to not prolong this lecture. We've created the basic functionality of our mappers. In the next part, we'll use our implemented mappings. See ya in just a minute. Hi and welcome to the second part of this lesson. In this lesson, I'm gonna transform entities into DTO. Let's have a look at the agenda of the second part. We'll do the changes in location controller. We'll do the changes in the template and create Postgres UUID extension. Finally, we are going to start the application. Okay, let's change the location controller. We should start our changes from removing this location list DTO. We should move it to the separate file. Let's name it location list dto.ts, and yeah, we can copy it somehow, and we don't need this prefix I, and we're going to export that interface. It's not going to be the list of strings, it's not going to be an array of strings, it's going to be an array of location DTO. Yeah. And here we need to change that. Yeah, looks great. We have location list DTO and location. Let's go back to the controller. We don't need it more. We just need to import such DTO. Okay, we can finally do the changes in the controller. We can change the constructor to additionally inject location mapping, not location mapping, mapping registry service here. Mapping registry service. Registry service. Yeah, looks okay. And we are going to use that mapping registry service. To do it, we're going to use public async method list location to return a promise for a location list DTO. Yeah, we are using the persistent layer. The persistent layer is communicating with the database asynchronously, so we need to handle that asynchronous way of rendering our application. We'll use our asynchronous method list. So to do it, we need to await for that list. Await is a kind of sugar over the promises, but makes the application even more readable. Now we will need to map all the DTOs. So we'll get our DTOs to a constant, and it's going to, our DTOs are our mapped location. So we are going to map our location, and we are going to map this into the location DTO. And we are doing it, we will do it using the location name. We are going to map location name into the location DTO name. And finally, we are going to map location object. Yeah, looks great. And we need to return DTOs instead of locations, but let's keep this name locations. Yeah, let's create additional space for return placement, and yeah, everything looks great. We'll also need to do a small change in the handlebars template. Let's go to our handlebars list template, and we'll need to indicate this dot name. Last but not least, in the last lecture we used UID type as an ID. Postgres need to have UID extension to properly handle UIDs. To create such extension, we should go to Postgres terminal using PSQL. Let's change the database to locations. To do it, we should use the command connect locations. Yeah. And let's create a proper extension. Create extension if not exist, and it's going to be UID or CP is how this extension is named. I already created that extension, that's why I had a notice that extension already exists, but don't worry, in your case you will just create a new extension. So we can check if the proper tables were generated. Yeah, looks great. I already created also a kind of fixture inside the location. Let's have a look. Location. Yeah, the fixture is generated. You can use just closer insert into location ID name values, and in this case it's going to be UID generate v4, and this function will generate unique ID, and we can choose the name and let it be nice location 2. Yeah, and we just inserted the second location with the second UID. So let's open the application in the browser. To do it, we need to run this application. Let's run our application using the npm run start dev. Possibly something might be wrong because that was a quite long lecture. Application is starting. Nest application successfully started. So let's have a look at the localhost 3000. And there's something not bad, not wrong. It looks like there's some kind of problem with our location name, but we can simply debug it using our debugger. We're going to debug Nest.js framework, and let's check what is happening. Let it be here. Might be here or here, and finally here. Okay, there is a problem. Cannot find module mapping registry service. It cannot be found because there is a wrong path. Yeah, we are going to get that module not from source but from the level up from in the directory structure. Same with location mapping, and same with common module here. Any other problems? I don't think so. Let's try to rerun that debugger. Debugger attached. Yeah, looks like it's working. And let's have a look. What are our locations? Our locations are great objects. So let's go to the step into. Yeah, we are inside. Let's go to our map method and we can check what's happening here. We are going to return the value. This value looks strange, but we can check what the automapper is mapping. Oh yeah, here is a problem. We passed an object as a class, not like an object. Yeah, that was the problem. I think that no more problem will be here. Yeah, we need to wait for application. Yeah, looks great. Let's go to the second point. Yeah, there are DTOs, the first one, yeah, the second one, everything looks alright. Application is debugged. Yeah, there are nice locations, there are 2 nice locations. Everything looks working and that's really great. Finally, there were some troubles, but you could find how to use the debugger also, and that this is the nice method of debugging our application. I really like it. Thank you for this lecture. I hope that I've brought up some mapping issue closer. It's really important in enterprise architecture to use DTO. Thanks them, we can achieve flexibility on the output. There is more work that needs to be done when we decide to implement DTOs, but we receive a lot of flexibility in exchange. Depends on the project, it might be enough to work with entities or continue workflow with DTOs. I decided to do that, to do the DTOs, because I promised enterprise ready node. It's a common enterprise workflow. It might be really enjoyable in the future. Let's move to the future in just a minute. Hi, thank you for being with me and Nest.js in this section. We've done quite a huge refactor and introduced a lot of additional concepts focused on persistent layer mostly. Please take a look at this picture that clarifies the borders of particular layers of the application. The persistent layer is focused on storing the data. Persistence abstractions such as repositories can be injected into service layer. Rarely we could use them in the controller layer, but we must force politics to create a service and refactor controllers if any meaningful business logic will be included. It might be more complicated over time, but the politics is up to you. I'm trying to not call repositories directly from controller because I have a difficulty in later control. The next picture will show you that in fact all the layers can operate on entity. DTO should be accessible only in the controller. With such foundation, we know that controllers should be responsible for mapping from entities to format understandable for the final API. It's a solid tested foundation that keeps your business logic independent on API or other infrastructure and allow us to create an application following the domain-driven design rules. So focus on business logic first. We'll focus firstly on business logic in the next sections. Unluckily, we did so many changes that we've broken almost all the tests. We'll fix and improve them in the next section. See ya in just a minute. Hi! In the last section, we did a really nice job implementing the persistence layer. Thanks that we achieved nice separation between the particular layers of the application. We've created a nicely separated controller, we've separated services with business logic, and created a persistent layer. That was a really huge refactor, and we've broken most of the tests. In this section, we'll make them great again. This section will focus on fixing all the tests and show you the correct way to mock the dependencies. Sounds like a lot of fun, so see ya in just a minute. Hi and welcome to this lesson. We did a really nice job by adding the whole persistent layer to the application. It's not the end of our journey. Although it was really fast, we need to slow down a little and fix all the tests we've broken and write new ones to cover all the functionalities. We'll start from fixing unit tests. I divided this lecture to a few parts. Let's check the agenda of the next few lessons connected with fixing tests. So in the next few lessons, we'll run unit tests, install sign-on and Lodash, we'll fix location.service.spec.ts, we'll create a mock helper.ts library, maybe not library, maybe it's just a simple helper, and we'll fix location controller.spec.ts. We'll create a lot of generics that will help us in the next lessons and in the future generally. So let's run our unit tests in the beginning. To do it, we'll need to use the npm test command. As you will see in just a moment, the tests of controller and service will not pass. Yeah, the tests are not passing. So let's check what's broken. Let's fix them. Let's start from location service.spec.ts. As you can see, we'll require an argument and it's going to be location repository, and we need to somehow mock this library. To mock such library, we'll use the mocking library. To create one, we'll use sign-on. Additionally, we'll need Lodash in this section, so please type npm install save sign-on and Lodash at once, and it will install sign-on and Lodash. We'll also need typings because both libraries have not included typings, and we'll need also to do the npm install command to install types for sign-on and types for Lodash, but we'll need to do it in the development part. To do it, we'll need to create npm install. We'll need to type npm install save dev, and it's going to be types sign-on and types Lodash. Yeah, we'll install needed typings, and we are going to fix that test. Yeah, I would love to create such lectures a little bit shorter than the last ones, because that was really huge. So I think that we'll finish our lessons for this moment. We'll have we've got the nice libraries installed, and see you in just a minute, and we'll fix this location service.spec.ts file. Thank you, and see ya in just a moment. Hi and welcome. We are continuing fixing our unit test, and we are going to fix location service.spec.ts. Let's start from declare what we'll need in before each section. And we are going to mock a repository because it's a unit test. We'll believe that a plain object is a repository. To do it, we'll need to create a mock repository property here, and it's going to be a type of repository, and this repository should be imported from type rm. Yeah, it's imported, and it's going to be a repository of location, and it will be imported from location entity. Yeah, looks great. And we'll do the blef. To do it, we'll create a plain object, but this plain object will be of type, will be cast to the type of repository of location. It's a blef. It's not an object of such type, but no one will know that except you. At least application will not know that. So then we'll assign the find function to such repository. To do it, we'll need to use object assign method to mock the find function to a repository. It looks great, but it's still not a mock. So we'll need to create a mock using sign-on. We'll need to import such sign-on library, import everything as sign-on is the proper way to import sign-on, and we are going to import it from sign-on. Yeah, looks great. And we'll need to create a mock. We'll need to declare mock, of course, mock, and it's going to be a type of sign-on mock. And our mock will be created using the method mock, and we are going to pass an argument. As an argument, we'll use the object to be mocked. In our case, it's mock repository. Finally, we'll create an expectation, and we'll use it. We'll use the method expects to create expectation, and this is the expectation of find method that will resolve to an array with locations. Yeah, looks great, but there is a problem. There's one problem, because it's going to be it's going to be challenging to create the locations. So let's at this moment just fix the location service by passing the mock repository and fix the test by adding the method resolve, because we're returning this empty array asynchronously, and we're expecting that our list will resolve to that array eventually. Yeah, and that test should be partially fixed. It means the test should pass. Yeah, something is wrong here, I think. Oh no, this test passed. This one with controller did not. Yeah, everything looks working, except the fact that we are returning an empty array, and we'll fix that in the next lecture. See ya in just a minute. Hi, thank you for the last lecture. And in the last lecture, we fixed the location service.spec.ts, at least partially, because we are resolving an repository the returning from the value returned from a repository is an empty array. It's a not usual case, so we'll need to mock some entities, the real entities, and to do it we'll need to create the kind of location entity factory. And location entity factory might be not the best choice because we can create the generic factory, and to create the generic factory we'll create a file in the common module, and this file will be named generic factory.ts. Yeah, and our generic factory will be a class, of course, generic factory. It looks awesome. And there will be one method inside, and it's going to be public static method create. And we are going to create a method that will be a type of generic, maybe not generic. It's going to be just a type of the unknown constructor, and the second argument will be the plain object with any properties we want. So it's going to be an unknown plain object, and this generic factory will instantiate our class. To do it, we'll need to use instance. We'll need to use the constant instance that will be just the instantiate class. It's exactly what the factory can do, but we'll also assign the proper properties to our instance, and we'll use the assign method of object to achieve it. We'll assign the plain object to our instance. Yeah, everything looks great except the fact that we'll not have the type that's going to be returned. So to have such type, because we don't know this type, we need to return the unknown type. But we can cast this unknown type to some generic one, like T. And yeah, that's everything will need to be done, because we can't use this type. Yeah, it's not the proper typing in a TypeScript word. We cannot find, as you can see, class name. We need to use the generic property to cast these types from this one to something different. In that way we can cast the real class to an instance or the abstract class, so it's not a bad approach. Yeah, and I think this is the everything I wanted to do in this lecture, and we'll use this generic factory in our location service and the rest of the application in the next lessons. Thank you, and see ya in just a minute.
Hi and welcome to this lecture. In the last lecture we created the generic factory. As you remember, we did it to create the real test here, to not return the empty array, and we just need to use it. It should be simple. Let's import the generic factory and create a new entity.
we'll need to use the generic type. It's going to be location that we are importing from the location entity, and we'll need to pass also the constructor here. The second argument, as you remember, is a plain object, and in our case the plain object should have has two properties. It's going to be ID and it's going to be name. Name should be simple because the name is chosen by me, location 1. ID is a little bit more complicated because, as far as you remember, we used the UID as our IDs, but we can simply generate the UID using the npm UID library. We will use this library using the node console. I typed node in the in our terminal, and we can just require the UID and use the method v4 to generate UID version 4. Yeah, we've created the nice looking UID. Let's create the second one, and let's copy this part to create the two locations. Should be quite easy and straightforward with our generic factory. Yeah, everything looks great. And as you can remember, we expect that the list method will return the empty array, but it's not the case. Let's check it. It's not the case because our mock repository will return two locations. So we are expecting in reality that this match object will have the two locations also. There is also the other fail. There is a fail with this path. Good to know. There's something wrong with my editor. I need to check what's happening here. But now everything is all right, so we'll check if the tests are passing. Yeah, it's location controller. And this test is not passing because we expect the empty array and we have the array with two locations. So let's just simply fix it, because we are not expecting our empty array, we are expecting the array with two locations. Yeah, exactly like this. Let's do the tests again, and the test should be fixed. Yeah, looks working. As you can see, the mock repository returns two locations and the service returns two locations also. So everything looks great, and in the next lecture we'll do some more cleanups here, because this before each section doesn't look great. I think it might be more generic before each. I will show you this trick in the next lecture. Okay, in the last lecture we did the nice working location service.spec.ts. It's a nice test, but we did a lot of code that potentially could be moved to some other place because it looks quite generic. To achieve it, to make it generic, we'll need to create the kind of helper. In our case, it's going to be mockhelper.ts, and we are going to create a class, export class mockhelper. Yeah, and this mock helper will do the two things. Will mock the we will mock the classes, so it's going to be a generic method mock. Yeah, with some arguments, and this mock helper will bluff. So we are going to just bluff that some object is a type of generic, and we'll pass the plain unknown object as an argument, and we'll just return this plain object as not unknown but as generic. Yeah, this method looks implemented nicely. So let's create a bluff with some mapped values. So let's create a bluff. As you remember, we've created some kind of bluff also here. It's a kind of bluff, and we are going to use this static method bluff, and we pass this generic type, and we are going to somehow create an object that might be a proto-bluff. To do it, we'll map the values of the object that will be passed here, and we'll pass here an object with key being a string, but the volume being something that I called an action. We'll not import this action, because our action will be in fact one of 4 simple cases. We are going to create the 4 interfaces, because our mock can resolve and we'll resolve, we'll do the action resolve like here, using the property resolve, but we can also not only resolve, but we can also return. And in case of not asynchronous but synchronous mock, will return instead of resolve, but we can also reject. Yeah, and in a synchronous word we will throw. Throws. Not throw, throws. Yeah, and as you can imagine, the type action will be just any of this interface. It might be resolve, returns, rejects, or throws. And yeah, and we'll also need to import the map values from Lodash, because as far as you remember, we'll create an object to be bluffed, and this object should have similar method created as the real object. So we'll need to map the mocks, we'll map values of mocks, to a functions. Yeah, looks like I expected. Now we can pass such a blef to sign on to create a mock. We did it exactly here. This step is this, and this step will be created in a moment. Let's create a mock and use the sign on. We'll need to import everything as the sign on from sign on library. Sign on mock, and we'll mock our blef. Looks great. For every key that we will find in this mocks section, for every key, we'll need to create an expectation. So let's create exactly what I said. Let's create a loop for every key of that step here. So of the keys of mocks, we should define the expectation. So in our case, it's going to be expectation, and mock expects of a key. Yeah, it's this part. Mock expects find in this case, but we are going to create something more generic. And now let's call the action like resolves in this case. To call such action, we'll need to check which action is going to be called. Let's fetch that actions from the keys of mocks, and for example mocks find or any other key. And we are expecting that there will be just one action inside, so we can just pop this action. And we need to just call this action expectation action mocks key action. What we did here is exactly this. We are going to do the action resolves with this volume. Yeah, everything looks great, and we need to return such mocked blef. Return blef. Yeah, and the mock helper it's implemented. Let's check what we can change in before each section, and we can change quite a lot because we will not need this part anymore. We'll also not need this part anymore. We'll need to just use the mock helper and we will return the blef. So in our case it's going to be mock repository, and we'll need to use it from we'll need to get it from mock helper mock, and it's going to be a type of repository with a generic location, and we are going to mock the method find that will resolves with exactly this. Yeah, and as you can see, our before each section looks much smaller and I think more straightforward, because we only use the one method, mock helper mock, and we are mocking in such case mock repository, and we'll mock the find method of this repository, which will resolve with such a value. So in that case, this test should work exactly the same. Let's test it with npm test. I can see what's wrong. Let's stop it and test again. Yeah, two tests passed. So I think that everything is working, nothing changed, except the fact that we did something, I think, nice, because we lowered the number of code needed in every test section. Now we'll only need this simple one method to do the mock. Thank you for this lecture, and in the next section, in the next lecture, we'll fix the controller, and it's the last unit test to be fixed. See ya in just a minute. Hi and welcome to this lecture. In the last lecture, we fixed the location.service.spec.ts file and created a nice mock helper. We'll use it in our location controller spec.ts to fix it and use the generic created before generic helpers. So we'll need to inject the location service inside the location controller, and we'll need also to inject mapping registry service inside. Let's remove this part and implement it again. We'll also need the mock location service here, and it's going to be a type of location service. And we'll also need the real one, mapping registry service. Yeah, let's fix the path. And mapping registry service will be the real one, because mocking the mapping registry service might be strange, because we need to somehow map these objects, and we'll need to implement these mappings again and do the same code twice that maps this service, one for the real mapping service and one for the mock. I think that might not be the cleverest solution. So let's do it in a clever way. Let's create a location mock using our mock helper and the mock method, and it's going to be a type of location service that will be passed as our generic. We'll mock the method list that will resolve with let's copy this from here because it might be similar. We need to also import generic factory, but our mock location service is created. It was really simple with our mock helper. We'll need to instantiate also the mapping registry service. To do it, we'll need to mapping registry service, create a new object of type mapping registry service, and we'll need to create also the location mapping service. That will be an instance of location mapping service, and location mapping service need mapping registry service as an argument. As far as you remember, mapping registry service will register the location mapping service, and to ensure that mapping registry service properly location mapping service, to ensure that location mapping service properly register this service, we did that we've created this this location mapping service. I think it's not needed now, but we can create the location controller that will be an instance of the real location controller with the mocked location service, and we'll pass also the real mapping registry service. Yeah, looks exactly as I expected. And now we can fix the controller test, because we'll no more return the list of locations. Instead, we'll create the list of DTOs, and the first DTO will look exactly like this, and the second one will look exactly like this. And we'll also need to make it asynchronously, so we'll resolve this list location, and then we'll expect the exact matcher. Finally, we are going to run the tests. Let's fix the paths also and do the tests. And just a moment, everything should work. There is a problem. There is a problem. Should return an array with element. We can change this description, because we should return an array with locations, and location is not defined. That might be a little problem. We'll need to import the location from location entity and do the test again. Yeah, the location looks like be defined in some kind of global scope for TypeScript. I don't know what is the location if it's not the location entity. That's quite a curious thing. Let's check it. Yeah, that is a kind of global TypeScript state. That's a kind of curiosity. You can fix it just by importing the location from location entity, and all tests are passing. Yeah, everything looks working. Looks like unit tests were fixed. We installed some nice mocking library. We installed Sign-on. Sign-on is really powerful thanks to implemented mocked helper. we will cover the 90% of mocking cases in simple and straightforward way. Our tests should look a little bit cleaner, look like fast it was to implement the mock in that location controller. That was really fast. In the next lecture, we'll fix also the end-to-end test, so see ya in just a minute. Hi! Last but not least, we'll need to fix end-to-end test. It's the easiest test to fix because it's a black box test. Our app behaves almost like before. There are just some cosmetically changes in the templates. Yeah, as you remember, we changed this name to use this object locations and the property name. And templates expect a new object format from controller. Yeah, locations DTO. So let's run the end-to-end test. npm run test end-to-end. We are expecting that the end-to-end test will fail. Yeah, exactly. There are too many locations and the locations are different. Let's go to end-to-end test. Yeah, we've got the string location 1, location 2 and location 3, and we are expecting nice location 1 and nice location 2. Okay, so end-to-end test failed. Let's change our object format. We'll remove the location 3 and we'll create an object with a property name and change this string to nice location 1. And same here, name. It's going to be nice location 2. Yeah, everything looks great. Let's run the end-to-end tests again. And we're expecting that end-to-end test will pass. Yeah, end-to-end test passed. Okay, all tests passed. It's not the best test because such end-to-end test strongly depends on database state. We should ensure consistent state of database before end-to-end test, and we'll do that in the next section of this course. We'll fix this test and create more tests shortly. Let's see you in just a minute. Hi, thank you for this section. We fixed all the tests. We'll create a new ones in the next section, but previously I wanted to shortly recap the concepts. Please take a look at the attached image. Let's divide unit and end-to-end test concept. Unit test should focus on the test of this single public method in mocked environment. I even removed dependency injection container to avoid additional testing ballast. There should be exactly one reason to change the unit test. Change the business behind the particular method. Please take a look. Dependencies of a tested service should be replaced by mocked dependencies. We can see the same here. On the other hand, end-to-end test is black box test. We are creating the request and we are expecting the response. Tests should not depend on internal implementation, only